It's very fitting that our current space pioneers, Audrey Powers and Michael López-Alegría, are with us today to follow in those footsteps from that historic first moon landing all those years ago. So Audrey and Mike will be describing their various missions, and they'll be talking a little bit about what they believe the future of commercial human spaceflight will be. As Betsy mentioned, we will be having our auction at the end of the program, so I would encourage you to stay on the line until 1 o'clock when our bids will close, and then we'll be announcing the winners. So let me start by introducing our first keynote speaker, Audrey Powers. Audrey is the Vice President at Blue Origin. She is the Vice President of Mission and Flight Operations. She's responsible for the new SHEPARD flight operations and training, vehicle maintenance, and launch complex infrastructure at Launch Site 1. And I understand she's down at the launch site today. Is that correct?
I'm very warm in Texas today.
Ah, wonderful. So Audrey is also an astronaut, and she had the wonderful experience of being on the second human flight for Blue Origin's new SHEPARD program, NS-18. Previously, Audrey served as the Vice President of Legal and Compliance for Blue Origin, but she was an engineer by training. She had almost 10 years as an engineer before becoming a lawyer. She has a bachelor's degree in aeronautical and astronautical engineering from Purdue University. She worked at NASA, and she has over 2,000 hours of flight controller time with NASA on the International Space Station program. And then after leaving NASA, she supported government satellite programs for Lockheed Martin. She also received a Juris Doctor in 2008 from Santa Clara University in the University School of Law. So with that, I'd like to pass it over to Audrey for her remarks. Thank you and welcome, Audrey.
Thank you very much, Sally, for having me. I'm going to attempt to share some presentation slides with you. Let's see if I can get this. Okay, I think it's happening. This should be opening in a moment. So thanks very much for having me today and inviting me on this very important day in human spaceflight history. I'm going to share a little bit with you today about what Blue Origin is, the purpose of the company that I work for, and the strides that we hope to make in commercial human spaceflight, and also a little bit about my background. Thank you for that very nice introduction, Sally. And also, Sally suggested that maybe I mention what I think we can do to inspire the next generation, which is something that's very important to Blue Origin also. So I'll touch on all those things a little bit today, and obviously happy to answer any questions that you all might have for me. So building a road to space is kind of a theme that you'll hear connected to my company, Blue Origin. We are trying to make it easier for more people to get to space in a nutshell. And that we think it's very important to create the infrastructure to help make that happen. So our vision is enabling a future where millions of people are living and working in space to benefit the Earth. And there's a lot to unpack there, a lot of nuances in that. But when you think of it breaks your brain a little bit to think of millions of people being living and existing and working in space when we've had really a few hundred in our history that have been able to travel there. And so how do we get from there to here? Or from here to there, the two gates, as we refer to it, that we are working on at Blue Origin is first radically reducing the cost of launch, and we're trying to change. We're trying to change the status quo that we've had in our industry for decades, where you throw away boosters after they are used once to launch something to space. This idea of millions and millions of dollars of consumables being used to travel payloads to space and people to space is something that we just have to change in our mindset and really in our DNA as space explorers. So from the very first days of Blue Origin, we started back in the year 2000. We have focused on reusable technology and primarily reusable booster and reusable engine technology. And the first vehicle program, which is New SHEPARD, we call that our first step in the technological progression that will be much larger vehicles and much larger engines that can carry more people and more payloads to space. So that theme of kind of step by step improving on this reusable technology is kind of the foundation of what we were founded on. The second gate that we talk about is using in-space resources. So I'm not sure anyone would disagree. We live on the best planet, at least the best planet that we know of at this point. It is perfect for human existence. It is it is stunningly beautiful. It gives us everything we need as humans to exist and to thrive. And what we also know is that the resources that we need, whether it's air or water or trees or gases or elements of any kind, those are finite in quantity here on our home planet. And we need to find ways to offload our reliance on those things so that we make the Earth last as long as possible. And so what we envision is that if we make it easier to get to space for more people, we will have dreamers and entrepreneurs and scientists and explorers discover all sorts of ways to use the resources that are available in space for us to use them there. And again, that's to offload kind of the strain that humanity is putting on our home planet. And there are so many companies that Blue Origin is partnering with, and others out there in the industry that are just coming up with the most amazing ways to locate and use resources in space. So those are the two kind of foundational tenets that you'll find in all of our programs at Blue Origin. And so a little bit about how I got to be working for this company and how I ended up in the position that I'm in. So as Sally mentioned, I studied engineering at Purdue. I wanted to work in human spaceflight my entire life. That's what I remember as a child, being enthralled with flight and space. And so I very much wanted to work in the spaceflight industry. And I went to Purdue for that purpose. Purdue has a long-standing relationship with NASA and with many other space-related contractors and businesses. And I went there because of Purdue's relationship with NASA. There were more at the time in the 90s when I went there were more civilian astronauts that graduated from Purdue than any other university. And so that was kind of a no-brainer for me. That was where I wanted to go and study. And so, and I have to say, it did exactly what I hoped it would do. My first job out of Purdue was at Johnson Space Center, working on the International Space Station program. This is a picture of me and my family in front of the famed Saturn V booster that is out on the front lawn of JSC. And I was very fortunate to join the team of flight controllers that built and flew the International Space Station from its earliest days. When I arrived there in 1999, there was one element of the space station on orbit, and when I left, there were multiple laboratories, and there was a continuous crew of 6 people, and just this amazing representation of engineering and technical success that we had built on orbit. And I would be remiss if I didn't mention that this is also the place that I first met my partner on this panel here, Mike L.A., I dug back through the archives, and this is a picture of me working console in the space station flight control room on STS-92, which was a very important mission for the particular subsystem that I worked on. This was back in the year 2000, and Mike L.A. was part of that crew, and that was the first time I had the pleasure of working with him. I also worked one of his subsequent shuttle flights, STS-113, which happened a couple of years later, both very, very important missions for my particular subsystem. So it's a little bit odd to me that, you know, and I think very representative that the people you meet in this, it's such a tight knit community that you can't really get away from each other. You just like your paths keep crossing despite what winding routes you might take through your career. You keep running into the same people, I think, in this human spaceflight endeavor that we're on. So after I left JSC, as Sally mentioned, I was working for Lockheed Martin on some government satellite programs, and I went to law school at night. And I'd always been very interested in law. There was a lot about, you know, liberal arts and business and law that really interested me, despite my career in engineering. So I was very fortunate to be able to go through law school at night. And that was originally how I joined Blue Origin. I worked for a few years in DC at a large law firm, always in the space, you know, representing commercial space industry clients. And I moved to Blue Origin as a lawyer, first joined their legal team about 9 years ago. And I had a heavy focus in regulatory affairs, government contracts in the you know, legislative and policy world of DC. So I was there a lot, and I worked a lot of very challenging and interesting topics with our government regulators and our government partners. So from the FAA and the State Department to NASA, just some really, really unique challenges that this new kind of burgeoning commercial space industry has brought to its government stakeholders and government partners. So I feel very fortunate to have worked in those circles. And one of the things when I was at Blue Origin, I became involved in the Commercial Spaceflight Federation, which is our industry group, headquartered, you know, based in DC, and that was where my paths crossed with Mike L.A. again. He was very, very active in that organization. At one time, led it for a number of years. So a very, very interesting time for me to be working as a lawyer in this industry. And this, I love this picture. I don't know if you consider this a career highlight, but this is me testifying before the House Transportation and Infrastructure Committee with a great colleague and friend of mine, Karen Chenoweth, who was a senior legal counsel for SpaceX at the time and now leads the government relations team at Relativity Space. And I was stunned when I stumbled upon this picture putting this presentation together, because in the background there, the young woman in the blue blazer, someone who is a great friend to me and I know also very special to Mike L.A. Her name is Sarisha Bandla, and she is the head of the government relations team at Virgin Galactic, and also had the distinct pleasure of flying on Spaceship Two last year on Richard Branson's famous flight in July of last summer. So I don't want to suggest that if you get into the regulatory field in commercial spaceflight that you might get a trip to space, but this is certainly seems to be a theme. I don't think it's on purpose though. So a little bit about New Shepard and the program that I am in charge of here. So it is our suborbital launch vehicle program, and it's named after Alan Shepard, the first American in space. And it very much follows a similar trajectory to his Mercury capsule. So it launches from our site here in West Texas, where I am today, and provides the capsule that detaches from this booster that's pictured here. The capsule travels through space for about 3 to 4 minutes of zero-G time before re-entering here on our range in West Texas. So it's a short, about 15-minute flight. And it's really, you know, I have been so surprised since we've started flying people on this vehicle. We've now had 5 human flights and flown, I think, 26 people or so. So many of them have said to me, and as I'm out talking to people like this, so many people have said to me, I was never interested in going to space. That was something that, you know, you had to be a professional astronaut and train for years and dedicate, you know, months and years of your life. You might go live on orbit for months or at least, you know, weeks in the form of a shuttle flight. And it just didn't have any interest in doing that. But this, like this New Shepard experience, I would do this in a second, just to get a taste of what space is, just to see the Earth from that perspective. And I think that was one of the really big questions. You know, when I joined Blue 9 years ago, we only had 300 employees, and now we have almost 8,000. And at the time that I joined, there was a real question, and we talked about this a lot in our regulatory and government circles, you know, what would the market for an offering like this be? I think we're all pretty settled that there's always going to be some demand for orbital launch capabilities and now interplanetary and moon capabilities. But what really is the market for a vehicle like this? And we've seen overwhelming response from people who never would have considered that space travel was something they'd be interested in. So that leads me to my role here. So as Sally said, I'm the Vice President of Mission and Flight Operations and in charge of the launch operations and recovery and maintenance team here in Texas. And I had the very unexpected offer to fly on our second human flight last year in October. And that was not part of my job description. It was not an original part of my remit, but on our second human flight, we had 2 customers who were flying with us. We had William Shatner, who many of you know, and then we had a seat that, unbeknownst to many of us, was kind of being held for the first employee, the first representative of Team Blue, as we call it, and that was unexpectedly offered to me. So this day, July 20th, is not only a special day for the industry, as Sally mentioned, but it's a very special day for us here at Blue Origin. It was the day that we flew our first humans on New Shepard. And as I said, we consider that to be very much the first step of what we hope will be millions of people eventually reaching space with our help. And so very, very meaningful to us. Those were the four people that we flew on July 20th last year. Obviously, our founder, Jeff Bezos, and his brother, Mark. And in between them is a wonderful woman named Wally Funk, who was a member of the original Mercury 13 group of women that NASA chose to train for the astronaut program, but who never flew. And she will famously tell you that she beat many of her male colleagues in a lot of that initial astronaut training. She's a very decorated pilot, tens of thousands of hours in a variety of aircraft. And it is one of the distinct honors of my career to have worked on the team that helped her realize her dream of spaceflight last year. And of course, this is the group of gentlemen that I was lucky enough to fly with back in October. And this, you know, probably the favorite picture of me ever taken. This is when we were up during our 4 minutes of zero gravity, looking back at our splendid planet. And I'll touch very quickly on the efforts that Blue undertakes to engage with the next generation. I think this is so important, and I know something that many of you are interested in. And our nonprofit is called Club for the Future, and we conduct outreach all over the world to teachers and STEM educators and other organizations that are interested in bringing along and inspiring the next generation. And Blue Origin, kind of at the beginning of last year, we conducted an auction to sell the first seat to our first customer on New Shepard, and that seat kind of notably went for $28 million. We were astounded at that, I assure you. And we donated all of that money to Club for the Future. And we additionally took 19 million of that to give to 19 organizations that are STEM focused and working on inspiring the next generation. So this is a very important part of our mission. We create curricula that we share with teachers and STEM educators across the world. We have a Postcards to Space program where we ask kids of all ages to draw on a postcard their idea of our future life in space. And then I am lucky enough to fly those postcards on New Shepard and return them to the artists that sent them to us. And then this is a picture after my flight of some of the recipients of those $1 million grants that we made, those wonderful STEM organizations. And I'll point out on the right-hand side of this picture, there are two amazing female astronauts, Sandy Magnus and Wendy Lawrence, who I cannot believe that I was, a young flight controller working their flights when they were at NASA, and they came to watch me fly to space. So that is everything that I had to share with you today, and I look forward to your questions. Thanks very much.
Thank you, Audrey. That was wonderful. And it sounds like you've had an absolutely remarkable career, and really wonderful that you were able to join that elite group of astronauts. So wonderful. So next, it's my great honor to introduce Michael L.A. So Mike is Axiom's chief astronaut and was the commander of the history's very first all-private crew to the International Space Station, which happened just in April of this year on the Crew Dragon Endeavour. This was the 5th time that Mike had been to the International Space Station. He is involved with Axiom's operational and business development efforts, but he has 40 years of aviation and space experience with both the US Navy and NASA, and he's had a variety of different roles in those two organizations. So as a naval aviator, engineering test pilot, program manager, NASA astronaut, and International Space Station commander. Pretty impressive. He also holds NASA's records for the most EVAs, extravehicular activities, and he has had cumulative EVA time of 67 hours and 40 minutes. That is remarkable. He was inducted into the US Astronaut Hall of Fame in 2021. And Mike has degrees in systems engineering. He has a bachelor's from the United States Naval Academy, and he has a master's in aeronautical engineering from the Naval Postgraduate School. So with that, I'd like to pass it over to Mike. Thank you very much.
Thank you, Sally, very much for that very kind introduction. And I tip my cap to all of you at the Washington Space Business Roundtable for putting this together, and the very good cause that it's serving. Also, a real pleasure to share the stage, so to speak, with Audrey. We do go back quite a ways. Actually, Audrey, I had no idea you worked STS 92. That was quite a while ago. More recently, though, we've both kind of been in the trenches working in the regulatory environment is probably the best way to say it, up in Washington. I'm here in Mission Control at Axiom headquarters in Houston. And I want to speak about AX-1, the mission that Sally just referred to. But I think it's probably wise for me to talk a little bit about my path to here, just as Audrey did. And basically, I was in the Navy, wanted to become an astronaut. Actually, I wanted to become a test pilot. And then I read some articles about all the graduates of the test pilot schools, Navy and Army that had, Navy and Air Force that had gone on to become astronauts. And, kind of reawoke a childhood dream that I had when I was 11 years old, and listened to the descent to the lunar surface from a beach in Southern California with my family. So I was accepted in test pilot school, went to graduate school, and then was hired by NASA in 1992. I had 20 years there as an astronaut, 4 missions. The last one is kind of why I'm here, and that is because I was due to fly on the Soyuz with a Russian colleague, Mikhail Turin, and the third person was what we called a spaceflight participant, so a non-professional astronaut. And I have to admit that I wasn't super jazzed about that. And I was quite skeptical of the concept. But the time that I spent with Anusha, a little bit in training, because she was actually the backup and became prime just a few weeks before the mission, but also the mission itself really changed my mind. And so when I left NASA a few years later, I actually went to work for the Commercial Spaceflight Federation so as to promote the agenda of commercial spaceflight and commercial human spaceflight in particular, because Anusha's experience of blogging from space, which was brand new. This is back in 2006, really affected me. And she was reaching out and touching hundreds of thousands, if not millions of people who otherwise would not have cared about flying to space or what's going on in low Earth orbit. And this idea, a little kernel of this notion of democratizing the experience, really hit home with me. And that's why I went to work for the CSF, where I worked closely with Audrey in a few different specific projects, and that organization was very fortunate to have her leadership later. So it was through that I got into the so-called new space world. I left CSF, became an independent contractor, and Axiom Space was one of my clients starting in 2016, which is when the company was formed. And I joined them because turns out I had been to the space station and they wanted to build a space station. And for once, it was a job that wasn't related to Washington, which I truly appreciated. Nothing against all of you who work there, but it's a tough environment for a person who's in the Navy and at NASA as an astronaut. It was a tough transition. Of course, I ended up doing some government affairs for Axiom in the beginning, but started getting involved with private astronaut missions, which is part of our plan to build a space station. So let me just talk for a second about that plan. We have an agreement with NASA to attach modules to the front end of the ISS. And the purpose, of course, is so that when the ISS is decommissioned, whenever that happens, we will have no gap in access to low Earth orbit. So our plan is to attach the first module at the end of 2024, the second about 6 to 9 months later, the third about the same period after that. And then the last module, you see there's a power and thermal module. In the short term, we'll be using some electricity and cooling capacity from the ISS, because those big solar arrays on board the ISS will be an absolute nightmare to manage. And so we want to wait until the last minute to bring those on board. But about a year before they start the maneuver to deorbit the ISS, we'd fly that up, of course, make sure it's checked out well, and then separate before they start lowering the altitude for an eventual deorbit. So PAM missions, private astronaut missions, are actually a step along that path. And NASA put out a solicitation for the first 2 of those missions. This initiative was announced in June of 2019, but the solicitation didn't come out until quite a bit later. And they selected Axiom Space to do the first 2 of those missions. And so I'm going to talk very quickly about AX-1, the first of those missions. And this is going to be a little bit like speed dating because I have a lot of images to show you, but so just hang on. Here's the crew, left to right, Mark Pathy. He's a Canadian businessman, kind of the only guy in the crew that didn't have some high-performance jet experience. He had done a lot of interesting adventure type stuff, backpacking in Africa and riding horses in Mongolia and things like that, but had never been in a high-performance airplane. Larry Connor actually has had quite a bit of time. He's an accomplished aerobatic pilot as well as a race car driver, but his real business is in real estate, and he buys and sells properties, generally big apartment buildings that they're basically like companies that are failing, and he buys them and changes the management and turns them around and sells them. He's very successful. He's based in Dayton, Ohio. You know me. And then Eitan Stibe is former F-16 pilot in the Israeli Air Force, but then left and became an impact investor, mostly in Africa. So his niche was creating development projects in these third world countries to promote infrastructure or to build infrastructure. He also was very close to Ilan Ramon, who was the Israeli that was killed in the Columbia accident. And in fact, the foundation that was formed in his honor and his name, the Ramon Foundation, is the one that helped Eitan put together a very, very complete science package. And I'll talk about all those a little bit later. So a few slides on training. The first thing we did was we went to experience zero G and on G-Force 1. This is a modified 727 that's operated commercially in the US. You can experience this anytime you jump off a diving board or a trampoline for just a split second. It's, the moment when you stop going up and right before you start coming down. And if you do it in this vehicle, you can do it for about 20, 25 seconds at a time. Suborbitally, as you've heard, you could do it for 3 or 4 minutes, but in low Earth orbit, even though the force of gravity is almost the same as it is on the surface, you're going so fast that you're basically in free fall around the planet. So this is kind of a fun exercise more than anything, but very rewarding. Just the smile on people's faces when they do this for the first time is pretty special. So we went from micro G to macro G. This is a centrifuge facility in Philadelphia. So we had the SpaceX Dragon G profile loaded here so we could sense what it was going to be like for both ascent and entry, as well as post splashdown, which was quite interesting. Then we did something that I thought was a good idea at the time. It's called the National Outdoor Leadership School, or NOLS. This is a page out of NASA's playbook that we borrowed. They often send crews or astronaut candidates out on these expeditions where you're in some kind of physiological discomfort. You're either hot or you're cold. You're generally hungry or thirsty. And it brings out certain behaviors, and it allows you to learn what they call expedition behavior, how to take care of yourself, how to take care of others, and how to deal with those behaviors that come out when you're uncomfortable. Notice them, head them off, cope with them, help others through them, etc. So we were in the Talkeetna mountain range in Alaska, and I can say it was miserable. We spent a week there. We had every precipitation known to man. This is in June of 2020, and it was, 2021, and it was miserable. It rained, it sleeted, it hailed, it snowed, it did everything. It was very cold. But they say what doesn't kill you makes you stronger, and we came out of that a very bonded crew, even though these are all very different personalities. And they're all, I'll admit it, they're all quite wealthy. And to have them go through this kind of unpleasant experience, I thought was very indicative of what kind of a crew these guys would be. And they all showed up and participated. I was very proud of them. We then came to the Johnson Space Center, and most of the training for the ISS has to do with emergency scenarios. So we do certainly get training on the galley and the toilet and kind of obvious things like that. But the most important stuff is what do you do if there's a fire, if there's a depressurization, or if there's a toxic atmosphere caused by the ammonia that they use to cool the system, the avionics on the ISS. So we spent quite a bit of time here. I would say the total training, including everything, is probably on the order of 4.5 to 5 months, spread out between NASA, Johnson Space Center, and SpaceX, most of it in Hawthorne. But, we have access to the mock-ups who are trained by the very same instructors that train NASA astronauts in the very same classes, although a subset of them, obviously. The SpaceX training was phenomenal. The last vehicle I flew was a Soyuz, and going from that to the Crew Dragon is like going from a Lada to a Tesla. Just an amazingly well put together, intuitive, very comfortable, and just a wonderful vehicle. And the team there at SpaceX was great to train with. They had trained a few NASA crews by then, as well as Inspiration 4, which was a private crew that did not go to the space station, but rather stayed in orbit for 3 days. So still pretty early on, but they had really done a good job putting the curriculum together. About a month before flight, we went down to the Cape and got to see the actual vehicle we fly in and get in it in our flight suits. So we train in training suits, and our flight suits are only used on 3 occasions. This is the first one. After doing all that, they roll the vehicle out to the pad. This is, mated to horizontally to the Falcon 9 second stage. And then it's just a very short trip out to the pad. They make it vertical. And the second occasion that we use the spacesuit is on dry dress, which is 2 days before launch. We pretty much walk through the whole scenario as if it were launch day. And then finally launch. I can tell you that I've been, to space 5 times, and it never gets boring. It never gets less exciting. I think I appreciated it more this time because I had left NASA long ago, never thought I was going to fly again, and kind of began to appreciate just how special that privilege of not only training and flying and working as an astronaut is, but being able to do it again, especially after being able to, I would say, evangelize the benefits of human spaceflight, was really just a wonderful privilege. Takes about 8 minutes and 50 seconds to get to space. The G's are constantly increasing. If you think about how the acceleration of a Formula One car from 0 to 100, that G spread out over 8.5 or 8 minutes and 50 seconds is actually less than what we feel going to orbit. So it's pretty impressive, but it's all comfortable because the G's are this way, kind of plus X through your chest and not from your head to your feet. So it's quite tolerable. We had 19 hours of phasing, which is basically what they call it from liftoff to the time that we were to dock. It's pretty much all automated. The vehicle does a lot of what we call burns, maneuvers to add velocity to gradually raise its orbital altitude to reach that of the ISS. And then the docking, we docked to the Zenith docking port on the ISS on Node 2, which is, I think, the first time humans have done that from Earth. And again, I tip my cap to SpaceX because of the automation is just phenomenal. We're standing there mostly in monitoring mode, but when you look at the ISS getting bigger and bigger through the cameras, same thing you've done many times in the simulator with a very decent representation of what the ISS looks like. But when you see it for the first time, it is staggering. And the next thing you see are people on the other side of the hatch, which is, again, an amazing feeling. And of course, then we floated aboard. This is the three crew, 3 Americans and a German, as well as the Russian crew. The 7 of them made up the Expedition 67, and the 4 of us joined us. So we were 11 on board the ISS. We got to work right away. I mentioned Eitan's experiments, but Larry also worked with the Cleveland Clinic and the Mayo Clinic, and Mark with the Royal Canadian Geographical Society, the Montreal Children's Hospital, and some other entities in Canada. And we had a super ambitious timeline. So this is not space tourism by any means. These guys trained hard, brought science to the ISS, and we did 25 experiments over 100 hours in the time we were up there, plus a lot of outreach. So that experiment that I showed is Eitan injecting a polymer into like a circular, an annular ring. And once the liquid fills the whole space, then he cured it in a UV light, and it hardened into a lens. So the more you put more liquid in there, it gets fatter and fatter, becomes more convex. Or if you just get it just enough for it to touch, then it's a concave lens. And those lenses are on board, and they'll come home on SpaceX 25, which just docked a few days ago. This is Larry also working in the glove box. His experiments had to do with stem cells. So basically he's adding media to a whole bunch of different cells. These are looking at senescence and also the heart cells, how they behave to microgravity with different types of, some more different kinds of nutrients that were given to them. Mark here is demonstrating the very first 2-way holoportation from space. So he was actually able to see, Obi-Wan Kenobi basically on the other side. And it looked to him like he was on the space station and vice versa. Pretty neat technology for things like remote medicine. And then, of course, we looked out the window. This beautiful cupola was not there the last time I was on the ISS, and we spent a lot of time in it. And I have to say that, you know, you've probably heard people talk about the overview effect, but it is absolutely true that when you see the planet from that perspective, your mindset changes just a little bit. You become a little bit more tolerant, more aware of the fragility of our planet and the society that holds it together and makes it habitable. And I think it is such a positive experience that this notion of democratizing it for other people, for more and more people than the scant 600 that have seen it, can do nothing but make the world a better place. Of course, we played with some food and liquids. We did a lot of outreach. This is a piece that Eitan did because related to that experiment that I mentioned with the lens making of how fluids behave. So every one of his experiments had a educational component, and this was the one that went with that. But there is no end to how much fun you can have in microgravity, and it was just a thrill to be able to work alongside the Crew 3 crew. They were very helpful to us in terms of showing us around and making sure that we were, first of all, safe, but also, I'll tell you honestly, our timeline was probably oversubscribed, and were it not for them, we would have probably not got all our objectives met. So they were super helpful, and we're very thankful to NASA for the cooperation. We spent, we're supposed to be 10-day mission, 8 days aboard the ISS, ended up being 17 days, 15 aboard the ISS. People ask a lot about, well, how do you, stay in touch? We have a phone that we can call any number on Earth pretty much at any time. We have scheduled family conferences that are two-way video. Obviously, we are only up there for a short time, and so it wasn't as huge a deal to us, but the long duration crews that are up there for 5 or 6 months certainly take advantage of this. And it's a wonderful capability to be able to, A, speak to somebody, friends, family, etc., but B, look at the planet as well. I think when we start thinking about going to Mars, that is going to be a very, very different situation. The time lag I'm sure are aware of, as well as, not knowing which of those white dots is planet Earth. I think it'll be a very different experience. So finally, after the delay that I mentioned was due to the weather in Florida, they have some pretty restrictive criteria for wave heights and wind velocities and things like that. But splashdown was smooth. Re-entry was super fun. There's a lot of G's for a little while, and then you're falling, and then the parachutes start coming out. And that's quite dynamic. It's a bit of a roller coaster. The last time I did it on Soyuz, I didn't like it so much. I had been in space for 7 months. That might have had something to do with it. But this time, we all felt great. And it was wonderful to be back on Earth. The splashdown itself was milder than I expected it to be. 37 minutes literally after we touched the water, we were on the recovery ship with the hatch open, which is a pretty amazing feat when you think of it. And then we all got out amazingly. As you can see, we're not a very young crew. I'm sure the oldest average crew ever in the history of human spaceflight. Although maybe the one with Wally and Jeff, I don't know. Audrey, you'd have to tell me what the average age was there. But everybody did great on the way up. Very little space motion sickness, which is quite common for astronauts. And also on the way down, again, it was much more like a shuttle mission than an ISS mission in terms of duration, but people felt well and did well. So I hope that wasn't too quick. I'm happy to join Audrey and take questions from any of you. Thanks for your attention.
Thank you, Mike. That was absolutely fabulous. And I have a million questions, but unfortunately, we probably won't have the time to ask them all. So I'm going to encourage the audience, if you have questions, if you could jot them down in the chat, and we will try and get to them before we run out of time. But let me just start. So, Mike, let's start with you. So you have just recently returned from the space station. This was the 5th time that you've been to the space station. But this was after 15 years. So I guess I have a 2-part question. What what had changed in those 15 years on the station? And the second part is, you were riding in this very comfortable Dragon. How did that compare? How did the uphill compare in the Dragon versus on the shuttle?
Well, let me do the last part first. You said versus the shuttle. Well, it's very different from the shuttle. Obviously, you have to get to a certain altitude at a certain time at a certain speed. So the physiological piece is pretty similar. The shuttle has a lot more vibration in first stage because of solid rocket boosters. But the ride uphill was quite similar to the Soyuz, which is like Falcon. It's all liquid fueled. I would say Dragon is quite a bit more comfortable than the Soyuz. The Soyuz is very tight. The shuttle is pretty roomy. Suits are a little bulky, but all in all, it's amazing how point design all these vehicles can be. They do virtually the same thing in very different ways, but they're quite elegant. The ISS had changed a lot. It's probably at least twice as big as when I was there last. The crew size back then was 3, now it's 7. It's very much more complex. There seems like there's a lot more cabling and stuff in the various modules because there's a lot more dedication to science experiments. When I was on board, we were still building it. And so we spent a lot of time, modifying things for future capabilities and not so much on science. But now there's experiments happening all the time everywhere. So it feels a bit more, I'd even say cluttered. But it kind of felt like going home to visit your parents in the house that you grew up in. So it's very familiar. Like there's a sense about it that, oh yeah, I've spent a lot of time here, even though it's been remodeled a little bit since then. So I felt very comfortable and remarkably like it hadn't been very long, but there were definitely some physical changes to the vehicle that were noticeable.
Okay, thank you. So, Audrey, a question for you. So with your strong technical background, or you both have strong technical backgrounds, but, and I know you've both been very active in advocating policies and regulations that really try to strike that right balance between public safety and encouraging commercial launch. What do you believe is necessary to be able to achieve that balance?
Well, I think something that we've worked an awful lot on in the industry group, we talked about the Commercial Spaceflight Federation, is figuring out with our government agency partners how to strike that balance. And the FAA, I think, took a big step forward in that regard with some of its recent regulatory updates. They've really focused on what are called performance-based regulations, rather than taking a prescriptive approach and telling companies, this is how you have to design something, or this is the technical approach you have to use. They try to establish safety standards that must be met. And then they tell the companies, you can come up with your own technical solutions and you can bring that to us and propose it and show how it meets our safety standards. So there's a lot more of a system safety approach to reviews of designs that the FAA has undertaken in recent years. And I think that's going to be really positive for the industry and something the FAA has been restricted from in recent decades is regulating the safety of astronauts on board these vehicles. So they can't regulate the design for the safety of astronauts. They can only regulate the safety of the uninvolved public. So people on the ground, people in the airspace, and that will probably be changing in coming years as these commercial endeavors become more common. And I think the government has really shown that they have the right kind of mindset to regulate in that way.
Okay. Looks like we have a question from the audience. So Courtney, if you can come off mute and come on camera, that would be great.
Sure. Thank you very much. And I'll make it real fast because I know that we've got a sharp 12:55 to let Seamus come on and close out the auction. But thank you both. One observation, then a question. Having had the honor of being in rooms and on conference calls with Mike, L.A., and Audrey, I have to say that in my judgment, I think having their operational engineering to inform their perspectives on the regulatory policy was huge. And this is not to discourage young people that are pursuing policy studies per se, but I think the mix of technical really is a very nice mix. Plus, they both have a temperament which allows them to interact with sometimes rather challenging personalities. So keep that in mind, young folks. My question is, both the organizations obviously are pursuing habitats, and I'm wondering, in a minute or two we have, if you could just very quickly spot some of the main challenges you see facing the establishment of those habitats, particularly what can the government do in terms of facilitating those habitats. So with that, I'll go back on mute. Thank you.
Audrey, do you want to go first? I'm happy to.
Sure. Well, I guess we have a lot of folks focused on the moon right now, and a lot of countries as well as a lot of private companies focused on the moon, in addition to NASA. And I think one of the challenges we've seen in recent years is the applicability of some of the Outer Space Treaty requirements. And so there's a requirement in the Outer Space Treaty for governments to exercise continuing supervision of activities that are undertaken in space. And I think we're still trying to figure out, the United States and foreign governments are trying to figure out exactly what that means. If we have a private entity go and land on the moon and set up a station there, what does the US government have to do to keep track of their activities and regulate in any way their activities? That's a big open question. Go ahead, Mike.
Yeah, I would say that as an agency, NASA is doing what it should be doing to help what we think ultimately will be an economy in low Earth orbit. I don't think they're doing it as fast as many of us would like, but keep in mind it's a giant organization. You know, this is all brand new to them. And I think these private astronaut missions are a step in that direction. They're allowing us to do things that are almost antithetical to them from a commercial standpoint, which, you know, is understandably difficult, but I think they're headed in the right direction. And from a non-NASA standpoint, as much as Audrey and I and others at the CSF are, pushing back as much as we can on having too much onerous regulation of human spaceflight, we probably do need to have some kind of regime in low Earth orbit, because I think having no regulation is sometimes worse than having, at least decent regulation. So this supervision that she mentioned is a sort of an excuse and a mandate almost for us to do that. And I think having some, light touch, favorable regulatory environment in low Earth orbit is a step that is probably important for the establishment of habitats.
Yeah. Oh, I miss working with you, Mike.
Likewise.
Couldn't agree more.
Okay, we're going to try and squeeze in one last question from the audience. So Daniel, if you can come off mute and go on camera and ask your question.
Hi there. So thank you very much for this very interesting call. My question is rather quick and simple, and it is, what are like the top 3 markets you see opening now that on-orbit operations, such as on orbital reef and on Axiom, will be available and that could be exploited by new space startups? Thank you.
Well, for us, it's maps nicely to our business development effort. So we think there is a market in private astronauts. So folks like Mark and Larry and Eitan, we call them professional astronauts, but you might want to call them government astronauts. So it's not just the folks that are using ISS today, but also countries outside of the ISS partnership that don't have the opportunity to use the ISS now can. And I think that is an important market segment. And the final one is all of the research and manufacturing that can be done in microgravity. The research is not terribly profitable. I think you'll see governments being the main sponsors for that, but some of the discoveries can lead to manufacturing processes that could scale. And we think that there is an untapped, or at least unknown, mother lode of possibilities. A bit, we always use the phrase that it's like the internet was in the 1990s. Like nobody could imagine the apps and the capabilities that we have today. And I think microgravity is akin to that kind of hidden treasure that we have yet to discover.
Audrey, did you want to comment?
I completely agree. I was going to mention the manufacturing aspect of it. I think, certainly what we hope to see is as folks move out to the moon and even beyond LEO, that we will find ways to make water on the moon, for example, or to use those resources for some of those more, manufacturing production based endeavors. So completely agree.
So I really wish we had more time. This has been absolutely fabulous, and I would love to ask many, many more questions, but we are going to have to wrap it up. I'd like to thank both Audrey and Mike for their really, really interesting presentations. Thank you for taking the time. We are now going to transition